Is my screen visible?
Yes, ma'am.
Okay. So in k-means clustering, the main parameter, as you already know, that is k. Okay, that is the number of clusters. So if we have n number of samples, we have to cluster the samples into k different classes, kind of. So that is the objective of this algorithm. Okay, and there are some constraint that needs to be followed, that all first thing is that there should be no common data points between two clusters. Okay, it shouldn't be overlapping clusters won't be there, and all the points has to be assigned to like at least one cluster, and there shouldn't be any cluster that has no point. Okay, so these are the three main constraints. Mm, so I'll explain the steps. I think Sir has already discussed, but just just for this, assignment. So the first step is to initialize the number of centroids based on the number of clusters that you want to divide the samples. Okay. Sorry. Oh. Okay. Um, here, suppose k equal to click 2. Okay, so for that, two centroids have been initialized. Now, after the first initialization, we have to calculate for each of the point, we have to calculate the distance from those two centroids. Okay, and whichever is closer to a sample point, it will be assigned to that particular cluster. Okay, you can see that these five are closer to this point, so it is kind of just I'll go to the next slide, then it would be easier. Okay, so suppose these two points are taken as the initial centers. Okay, so depending on that, this values are these sample points are assigned to cluster. This is the first cluster that are created. Okay, this next step is to calculate the mean, because it's a game is clustering. So you will calculate the mean of each of the cluster, and these mean will be assigned as the new centroid. So again you have to repeat the process. Once the new centroid is calculated, then again for each of the sample point you have to calculate the distance from the two centroid and accordingly assign it. So this process has to be repeated. So it is simple as, like, all these steps are like same steps are explained here. Assign how to assign each of the samples to the nearest centroid. Okay. And the stopping criteria, there is some stopping criteria. In this one, it is mentioned that if the distance between the two centroid, if it is less than a threshold value, then you'll stop with the update of the centroids. Okay. Okay. If I go to the next PDF, this is for satellite images. Okay, and for this assignment, there are actually two questions that you have to do. First thing is to implement the k-means clustering for the satellite images, and second is Shiloh coefficient. You have to calculate. I'll explain it. Okay, just. Okay, so for this one, you can start with two clusters, k equal to 2, and depending on the number of clusters, you have to show the input that the pixel, which pixel belong to which clusters, like that. Okay. And yes, you have the RGBI image. So the number of features you have are 4. Okay. Uh, don't get confused with the pixel coordinates and the features. Okay. Here in this example, the x and y actually represent the features. Okay, not the pixel coordinates. So don't get confused about the pixel coordinates and this xy coordinates. Yeah, if you go through the steps, that first thing is mm, to initialize the centroid, that you have to pick randomly. Okay, so after you pick the initial centroid, then you have to perform uh, the clustering. So the clustering, the steps for clustering is mentioned, and the first thing is you have to assign the each of the pixels that are the sample points to corresponding centroids. Uh, whichever is the has the minimum distance, you'll assign it to that particular cluster. Okay, and next thing is to update the centroids. And whenever the stopping criterion is satisfied, then you'll stop it. Okay, the same thing. Only thing you have to keep track of that the pixel values and the coordinate point don't get mixed up with that. Okay. Once all the class data, that is the that actually contains the xy, that are the pixel positions, also also which class or the cluster that has been assigned to it. Okay, so once you have this class data, then accordingly you can color uh, corresponding to the class. Okay, color is a variable that is taken as like this. So if you have two clusters, then you can take this any two values, RGB values, and depending on the number of clusters, the number of color values will be there. Okay, so stopping criterion, as I told you that there can be more than one stopping criterion, or like you can choose any one of them. One stopping criteria can be that if the previous centroid and the updated centroid, if they both are same, then there is no need to update, right? Like no need for further update. Then you can stop it. Another thing is that you can compare the pixel values of the centroid. If they are similar, and the difference is less than a threshold value, then you can stop. Another thing is if the number of updates you have done is mm, like you can take it as 1,000 or 100 or 500, like that. If it crosses that, then you can stop update the update process. Okay. I'll discuss about this Shiloh coefficient. Okay, once actually this one is not particular for the k-means clustering. There are other clustering processes, like hierarchical clustering based on tree. So any of the clustering methods are generally evaluated using this Shiloh coefficient. Okay, so once you have this class data, that is your the result, that which pixel is assigned to which class. Once you have this, for each of the pixel you have to calculate this Shiloh value. Okay, so how do you calculate this Shiloh value? uh, this is actually similar to the LDA that you guys have already studied. So it actually first measures the distance between uh, all the points in the same cluster. So suppose that P is assigned to cluster 1, then you have to measure the distance of all the points in cluster 1 from P. Okay, then you have to take the mean of all the distances. So that I've assigned as d1, and this value is actually will be used for the Shiloh value. So it is denoted as okay. And the next step is that you have to calculate the distance of the you have to calculate the distance of the point from the neighboring clusters. Okay, so to this will be calculated same way as the d1, only that you have to calculate from the points of the other clusters. Okay, so suppose p is assigned to cluster 1, so you have to calculate the d2, d3, d4. If there are four clusters, then you'll have to calculate d2, d3, d4. Okay, and out of that, whichever is the minimum distance, that you have to take as vp. Okay. uh, and this the Shiloh value that is calculated using this formula, that bp minus ap and divided by maximum value of bp ip. So what does it signify? It actually signifies that how much the point is properly assigned to a cluster. Okay, so if the values are of the pixel is similar to its neighboring, like of the same like the all the pixels that are assigned to the same cluster, it means that the point is kind of correctly classified. Okay, so that's why if ap value is small, then it means that uh, the the sample point belongs to that particular cluster. Okay, and if the bp value is uh, higher, it means that the clusters that the neighboring clusters are actually at a distance from the sample point. Okay, so if sp value is closer to 1, it means that the point is correctly classified. And yes. Okay. So for this assignment 10, first thing is you have to calculate for k equal to t 2, 3, 4, 5, and apply the k-means clustering on the satellite images. And also in the second point, you have to calculate the Shiloh coefficient for all the cases, and you have to plot it for 2, 3, 4, 5. Okay. There is another point, that is the k medioids. So once you have done k means, then I'll explain about like later. Just get like try to understand the k means, then I'll explain about the k medioids. Okay. If you have any doubts, you can ask.
Hello, ma'am.
Yes.
In this stopping criteria, if you can share the slides again.
Okay. Yes.
In the stopping criteria, we can use any one of them, right?
Yeah, any one of them.
Okay. So if we, what should be the threshold value in case of second and the second one, second stopping criteria?
You can take it as one or two, because the pixel values, uh, they won't be in floating points, right? So you can take one or two like that, maybe.
Okay, okay, ma'am. Here, all the distances we have to calculate with the pixel value, not the coordinate value, right?
Yeah, yeah. You have to calculate because pixel values are the four values that you have, they are the features. So whenever you are calculating the distance, you have to calculate between the pixel values.
Okay, ma'am. Okay, can you move a bit down?
Yeah.
Here, after calculating silhouette for each of the pixels in any cluster, what
Hmm.
is the last part? We have to select the maximum for each cluster.
No, not for each pixel you'll calculate SP, right? So your S will be 512 cross 512 number of pixels. So out of all the pixel you have to calculate, take the maximum value.
Okay. So for like complete data set only, we'll have for one particular K one value of silhouette coefficient.
Yes, yes, yes.
Yeah. Okay, ma'am. Got it.
Okay. And the Shiloh value won't cross 1. Okay, it lies from -1 to 1. So it will be within that range.
In the
एक
output
तुम्हारा
part of
डाटा
it,
Ma'am?
मिशन है,
can you
और
move
डाटा
down?
मिशन के आगे एक तो लेनोवो का कुछ है सर्विसेज।
Yes, yes.
Ma'am, can you provide the
हाँ तो
images,
मेरे पास डाटा मिशन
satellite
का है,
images?
तो बता दे दो तुम।
You don't have the images.
No, ma'am.
In the previous assignments, the satellite images will be there. Can you please down because I don't actually have that 512 cross 512 that particular uh, re- for the particular resolution. So if it is possible, uh,
It
any
should
of
be
you
with you.
remember
The
which assignment upload it in the assignment? Wait.
Hello, ma'am.
Yes.
Ma'am, yeah, ma'am. Ma'am, could you please explain this A point of second bit in the Shelloid coefficient? Means if in each cluster, suppose we are having K points. Yeah, ma'am, you were at that point. Yeah, ma'am, this eighth
Yeah.
point. Yes, ma'am. Ma'am,
Yeah.
in each
So,
cluster. Yeah, ma'am.
hmm. Yes, yes. Continue.
Yeah, ma'am. Suppose in one cluster we're having K points, we need to calculate the distance of a single point from all K minus 1 points, right?
Yes, yes.
Then, ma'am, that way we will be having K minus 1 cross K minus 1 distances. Then, how are we going to? Like, I was confused in the dimension we will be getting as the output.
No, you are calculating the shielded value for one pixel, right? So you have to calculate all the distance from all the points. The suppose m points are have been assigned to cluster 1 and p is one of them. So you have to calculate m minus 1 distances and you have to take the mean of all the distance. So it will be a single value.
Okay, ma'am, got it.
Excuse me, ma'am.
Yes.
Ma'am, here to initialize centroid, we have to take like for k equals to 2, we have to take two random values of x and y. Matlab two values of x and two values of y coordinate. And
Yes.
whatever will be their intensities in all the four bands, we would initialize the both the centroid according to those intensities, right?
Yes. Yes.
Okay, ma'am. So we don't have to take random values of intensity, but the
No, no.
values of the intensity that we get from the random points.
Yes, you have to randomly select the XY coordinate, not the pixel values.
Okay.
Yeah. Hello,
Yes.
madam.
Hmm.
Yeah. While assigning the points, the similarity measure is with respect to intensity, right?
Yes, with respect to intensity.
And
The
for
pixel.
calculating the new centroid, it
Hmm.
is the spatial distance.
No,
The coordinate distance, na, for calculating the new centroid point.
no. It will also be the intensity only.
Okay.
Okay. Um, Santosh, right? You just shared the four images, satellite images, right?
Yes, ma'am.
Okay, thank you so much. Sheetal, you can download it from there. Okay, that's it.
Yes, ma'am, I got it.
Hello, ma'am.
Yes,
For the first time only for calculating the randomly selecting the centroids, we'll select the XY coordinate. For the next time onwards, we'll
hmm.
just calculate the mean from the pixel intensities, right?
Yes, yes.
Okay, ma'am.